Hello. In this video, we will talk about ionic bonding and covalent bonding. But before we understand ionic bonding, we have to understand what and how each column or each group behaves. So the atoms on the left side of the periodic table, such as lithium, or I can say S block elements. So lithium and sodium, for example, they lose one electron in order to attain their stability. But the ones which are on the right side of the periodic table, like fluorine, chlorine, oxygen, nitrogen, they all gain electrons in order to fill their octet. So, but hydrogen atom, which is the first atom, it can either gain an electron or lose an electron. So when the hydrogen loses its one electron, it's going to form a proton. And the proton is so stable because its outer shell is empty, or you can say it's completely empty. But when the hydrogen atom gains an electron, it is going to form an hydride ion. And it is also stable because the outer shell is filled, which is going to be helium configuration. So that is the speciality about hydrogen. Now, the ionic bond is formed by the attraction between the ions of opposite charges, usually the one on the S block elements and then the one on the P block elements are going to come together because they are of opposite charges to form the ionic bond. So this is about the ionic bond. Now, covalent bonding, it is formed by sharing electrons. So covalent bonding can be classified into non-polar covalent bond or polar covalent bond. So the non-polar covalent bond is the bonded atoms are the same. It could be two fluorines, two chlorines, two hydrogens. So that is and also the carbon. Carbon also forms a non-polar covalent bond. We will talk about it little bit detail in the next slide. And then the polar covalent bonds are whenever you have two different atoms, or the atoms from the opposite sides of the periodic table, from one from the left side and one from the right side coming together, that will be a polar covalent bond. So the bond polarity, see, if you observe the electronegativity, it increases down the group and it increases as you go up the group. So it increases from left to right and up. So you can consider it as an inverse, inverse L shape. So the non-polar covalent bond, if you see the carbon is right in the center. So it will only share electrons. It will not form an ionic bond. So it's going to form a non-polar covalent bond because it's right in the center. So with hydrogen, lithium, beryllium, boron, it can act as a positive, and with nitrogen, oxygen, fluorine, it can act as a partial negative. So that way, it is considered as a non-polar covalent bond. And whenever you have polar covalent bonds or ionic bonds, they are going to have a dipole moment. So before we understand dipole moment, let us talk about partial positive and partial negative. You see the symbol around here, it's called as partial positive and this is partial negative. So because they are sharing electrons, they exhibit only partial positive character and a partial negative character. So the one on the right side of the carbon are considered as partial negative, and the one on the left side, like hydrogen, is considered as partial positive. And the dipole moment is pulled towards the negative end of the bond, which is like partially negative. So if you look at here, so the greater is the difference in the electronegativity, the greater is the dipole moment, and the more polar is the bond. So if you see hydrogen carbon, they're very close. So see the dipole moment is only 0.4. Consider hydrogen and fluorine. They are in the two corners, so the dipole moment is 1.7. That is the reason fluorine is more electronegative. That's why the dipole moment is pretty high. So I will not cover this. Let us stop here and let us call it a day for today, and I'll go into part 3 in my next video. Thank you.